Yeah, we'll get to that. But yeah, Mr. Motion Magnets and Montagraph, I think we're definitely going to have a bit of a chatty-do about the concern at CERN. But first of all, yeah, you almost have to hide your research these days. They're claiming it's a bird bath. But hang on. One thing at a time. Okay. So that's basically, you can do that. Okay. So we can actually turn it around, force some motion at a distance. Okay, at stage one. Because I think I've worked out your problems, fellas, or Mr. Motion Magnets making much ado about nothing, sort of thing. I'm not being negative there. I'm gonna surprise you, Mr. Motion Magnets. I think I've come across the reason why everyone around the world is got a 2/3 chance of not being able to, do things, and a 2/3 chance of causing gating, and therefore also a 2/3 chance, by chance alone, of not being able to reproduce other people's work who may have accidentally cracked things, sort of thing. So, okay. Now if we put this down here, we can actually do this. So basically, if you're the wise among you, should realise that this is basically a very simple, in a way, early proof of the concept. So I've got two things spinning in circular motion. In other words, we can get a linear drive off that way. So that's basically what this is basically telling us, is the linear approach making which is that's the one point that Mr. Motion Magnets makes, is if you can do it on a linear track, then it should work in a circular motion. He basically says, is implying that if you can do it on a linear track, you really can forget about the circle, because basically by bending a linear track round into a circle, it will work, sort of thing. But if you can do it on a linear track, unfortunately, I don't. Any access to rails and stuff is hidden away in a box in my son's room, so it's access is a bit of a problem. But I might be able to set it up with something more like scale electric dinky toy car thing. What do they call those little toy matchbox cars things going down on plastic chute, which are no good these days. Have you noticed that these days? The cars are crap. They're not heavy enough, and the tracks are rubbish to work properly like they did in the old days. For my childhood, you could do all sorts of things in my childhood with those things, and they'd always work. But now it's all rubbish. The track is rubbish. The cars aren't the right weight. They've gone soft on the metal or whatever that is in there, and they're just not heavy enough to remain on the track and all that sort of stuff. Anyway, I digress. Now let's get over to this part over here. And I'll just show you. And yes, I bought my iron filings out here to help. Now, don't poo-poo iron filings, because that idea was invented by Michael Faraday. And he used that to work out what no one else could work out, what the basic details. So he could actually see the lines of force using the iron filings, and he used that to actually make the world's first electric motor. So he was the very first person using iron filings to be able to grab the principle of what was going on with the field lines and everything, to actually be able to build the world's first electric motor. So don't anybody ever poo-poo iron filings as a tool or aid for seeing the so-called magnetic lines or fields of force. We'll get to that in a minute, but I just want to get my tripod. My tripod is because I've only got, like everyone else, most of everyone else, I've only got two sets of hands. Oh yeah, people coming back from Afghanistan and all that. Yes, I have seen some of those filthy, nasty, dirty little videos. But apparently, there's even worse now out there, which I haven't seen. Supposedly burying children alive. And I think, no, that's definitely, you have not only crossed the line, you have gone into enemy territory doing that. And I think we're just going to wipe you off the face of the planet. Burying children alive, no, that's it. Any civilization, you do something like that, basically you've crossed the ball of Pax Romana, haven't you, really? In Pax Romana, you always give a person one chance. We go and fix everything up. Second time, we just wipe you off the face of the planet. I mean, if it was good enough for the Romans and that, I don't think it's good enough for us. But anyway, now this is what I basically, I went and I said, you know, I couldn't work out why these things were sort of, you know, why I was getting so much better push by it being slightly raised up. But deeper than that, or so simple, is watch this. It's the way they magnetise these things. You know, you think this is a bar magnet, right? You think this is a bar magnet, and you think you've got a north, and you think you've got a south there sort of thing, but you haven't actually. But I'll show you something here. Watch this. So, magnets, repulsion. So if you've got like two norths there and two, you know, assuming that two souths there, you turn it around, you still got repulsion. Okay, you turn it around, so you've got the facing poles, you've got repulsion. Do it again with the sides like this, you got repulsion. Turn it around and snap, something happens and goes wrong. Same thing here. If you have repulsion on the side here, turn it around, snap. Again with this repulsion here, turn it around, snap. Blah blah blah, repulsion here, turn it around, got snap. So we got basically a six-sided object. We have four ways of going, you know, being incorrect sort of thing. So basically what this is saying is this is either the north or the south, depending on, of course you can work that out using a compass, which we'll try later. So basically if you build this up and stack more and more of these things together, basically if you stack these things together, basically that's your north and this is your south, basically. So this is really your bar magnet like that. Okay, so now you got repulsion, but now you got repulsion all the way around, you see, no gating on the poles. So you got no gating on the poles, you see. That's your problem. You get gating when you use the other four sides of the thing. That's where you get your gating problems. Because the way they impulse make these magnets, you think you've got a bar magnet like that, whereas really you've got the bar magnet like this, and you've got 2/3 the possibility of getting gating, and only 1/3 of not getting gating, sort of thing, if you understand. So, if we get my, yeah, light lime green, a purple, a light blue or turquoise. Now is that a light purple or a dark purple? That's a good question, isn't it? Anyway, let's put a magnet under here. So you think it's a standard bar thing, you think, oh, we're going to get a north there and we're going to get a south there. So you put your iron filings down here. So without your compass or using your other magnets, it gives the impression you've got yourself a standard bar magnet when really you haven't in that orientation, or well, it's not really configuration, but you know. Did you understand that? So really, that is either the north or the south pole. I think I should, you know, either stop this video and go inside and get my compass, and maybe I'll say that for another video. But I do have a compass and we can actually play around with it. But what I want to do is get on to the next step, which is, so you got your north pole here. Now if you just, as I said, I was doing this, the way I discovered this by accident is I was doing this, I was getting this repulsion activity here going on here, repulsion, like that. And I was bringing my my standard magnet in here, and I got repulsion there. I was getting well, I should, you know, so I was getting repulsion there and I was getting attraction there. So I thought I had my north and my south, which I didn't really. But, and then we got my repulsion there, so I thought, well, I've got two souths there, but what I didn't, so what I failed to notice was I got repulsion there, and when I put it up here, it seemed like the pole had changed, and I knew, so hang on, there's something wrong there. Of course, as I said, I investigated further, and basically what I've discovered is it's the way they make these magnets and not the way you think they make them. And you've got 4 out of 6, or 2/3 possibility of ways of actually getting things wrong and causing gating. So there you go, Mr. Motion Magnets. There's partially your answer of why you're having so much trouble, and I don't think you'll have trouble more. And Now this is your idea of your linear track. I'm going to show you this. So then I said, well, why was it I was getting better force there? Because it's the square of the distance, of course, and also multiplied by, I think it's opposite O hypotenuse. Is that the sine? So it's going to be some 0 to 1 multiplied by the square. In other words, you can very quickly get up to between 3 and 4 times by raising it up at an angle, sort of thing. Okay. What I've discovered is all you have to do is keep it in this sort of square sort of region here. As long as you keep this like staircase sort of pattern. Basically, what you're doing is you're just shifting horizontally your north or your south pole across. Hang on, I've got one that's stuck together from other. I've got 2 of them actually stuck together from other experiments. Get those away, and we slide these things over like that. And now you're fine. I don't know whether we're going to have to glue them or put a wedge in there or something, or just use a normal blue tack sort of thing. Now you should find you've got this repulsive force, but there's no gating. So Mr. Motion magnets, can you already see that if you had a whole line of these, or even 2 lines of these, you should be able to get your carts to work quite well, as long as you keep your magnet on your cart at an angle, so you get this repulsive effect sort of thing. And eventually I'll probably get to that, but I don't have all those carts and stuff that you do all ready to go. So you want to test this out, you should be able to reproduce this very quickly now, because now you know what's going on basically, and so does the whole world. What the problem was, you got a 4 out of 6 or 2/3 chance of buggering these things up and getting gating, which gets in the way of what you're doing. And why people are also trying to use attraction, I can't understand. To me, once you've attracted something, you're going to stick and you're going to get friction, and you're going to get it's going to stop, and you'll get the problems of inertia coming in there. You have the 2 sides of the coin of inertia, of course. But anyway, now what I've also noticed is you've got this strength on this side here and down the middle and things, so you could actually have 3 train lines on the top there. And underneath, you could have 3 monorails. So you're getting 6 functions out of your one structure. So if people over in China built something, and they started off something the size of a car, and they started building things the size of a house, eventually they say, well, this works, and we're going to build a big track and thing, and we're going to build it the size of, on the scale of museums or something, big tracks, the thickness and width and breadth of, and we're going to run 3 train tracks across the top, and we're going to run 3 monorails down the bottom or something like that. So you get 6 times the value out of your one build sort of thing. Okay, that's basically, I think, what it is enough for this video, I think. But the next video we're going to go on, I'm going to try and go down the Mr. Motion magnets pathway, or trying to do it on a linear scale. But I think you realise from the low friction example over here, using this, basically you can already see it's going to work on the linear scale, because you've got two circles working in opposites, and it gives you your linear motion anyway. So you've already got somewhat of a proof of the linear motion concept of this sort of configuration sort of thing. So I hope you understand that, and we may do some more of that later on. But I think the next thing is maybe get back to the wheel and do a build. But as I said, because these are close together now, like that, I'm going to need a lot more magnets. I'm going to need, let me see, 1, 2, 3 times, 3/4 more or magnets, I would say, to actually complete the same thing. I went into the shed the other day, and I do actually have another pack, so I must have thought ahead about 3 years ago, thinking, well, maybe one day I'll crack what the problem is and be able to move on. So, and I think I'm going to be able to move on very rapidly, and I think by Christmas we'll actually have a working, couple of really nasty, shitty working prototypes that's just going to set the whole world on fire, sort of thing, don't go rocking my dreamboat sort of thing, so we're going to set the world on fire, because all these people around the world have had problems, and now you know why you've had your problems. They impulse make these magnets in a way you probably didn't realise how they make them, and as I said, if you think that is your standard bar magnet, no, it's not. That's your standard bar magnet sort of principle, that way, not that way, sort of thing, So it's not north-south, it's north-south or south-north, depending how your compass reacts to it. Okay, I think that's enough for this video. It's way too long, but you know, it'll be worth it, I think. Some people will get a kick out of it, especially Mr. Motion Magnets and maybe Montagraph, because I think we're going to have to talk about Leo Szilard proving the principle of, you know, water then to heavy water, slowing the neutrons down so they can actually hit the nucleus in a longitudinal wave fashion, I would say, you know, like a Newton's cradle in a way, causing, you know, various forms of fission sort of thing, you know, rather than... so I don't think people get the idea how the young single and double slits could actually work. You can actually have photons moving from place to place in a transverse fashion, but they interact as particles in a longitudinal wave fashion. And that... the combination of those two different ways of travelling and interacting will probably give you the answer to your young single and double slit problem, and a few other things too. So I reckon all this thing now, once we get this going, all those equations, everything else that's been bugging us is just going to fall into line, I reckon. You know. Okay, over and out for this video. See you.